Remember what makes this a rational expression is that I have a fraction, a polynomial divided by a polynomial. That's why we reviewed these. Now, when we're asked to reduce these, as tempting as it is, you look at this problem and you think, we'll cancel out the x squareds. That's why I showed these silly examples up here. I can't just cross out a 2. And when it's addition, I can't just cancel out. That's not allowed with fractions, not allowed with rational expressions either. What I need to do is be able to factor it, and that's what I'm technically doing is when I cancel, I'm dividing. So what we really want to do is factor. We want to have prime factorization, but we know how to factor polynomials now. Factor in the numerator, double parentheses, double x's, right? My binomials. X times x gives me the x squared. Tells me they're both going to be the same sign. Tells me they're both going to be positive. 2's nice. 1 and 2. Positive 1 times positive 2 is 2. Positive 1 times positive 2 is positive 3. My denominator, a little bit easier. Hey, that's a difference of 2 squares. X plus 1, x minus 1. Doesn't matter what order you put them in. But now that we have it factored, the same way up here when I factored and I was able to cancel out the 2's, divide by 2, divide by 2, I'm able to cancel out the x plus 1, divide by the x plus 1, divide by... Because remember that x is a number. If x is 2, 2 plus 1 is 3, 2 plus 1 is 3, I'd be canceling out the 3's. If x were 27, 27 plus 1 is 28, 27 plus 1 is 28, they'd have a common 28. Whatever x is, that x plus 1 is what's in common. My reduced form is x plus 2 divided by x minus 1. Since it's just a binomial, it doesn't need to be in parentheses. Now, when we're asked about stating restrictions, remember restrictions are when my denominator equals 0. Well, remember, my denominator, it's at this point right now that it's factored. I would have just needed to be factoring it anyway. Even if I set this equal to 0, I would need to factor it. Over here, once it's factored, this is the prime time of when you'd want to find your restrictions. Now, we could set each of those equal to 0, but what we could also say is x can't be negative 1, x can't be 1. If I were to state my restrictions, that's what I would have is x can't be 1 or negative 1. And it wouldn't matter what order I put them in, but remember, those are the numbers that if I plug them in, 1 squared is 1, minus 1 is 0. Negative 1 squared is 1, minus 1 is 0. Now notice, even though they canceled out, even though negative 1 would be acceptable back here, anywhere, any denominator, anywhere in the fraction, if I get a 0 in the denominator, it's a restriction. I can never divide by 0, even if it's in the middle of a problem. These are my two restrictions for this problem.